Hello, I want to do a short video on this week's lecture material. So if we go into week 7, and uh, actually it's in week 6 is the PowerPoint. So last week we went up through the VPNs. So let me get to that section. And with the VPNs, we mentioned, well, let me start here again. With the Ethernet is the standard, right? And Ethernet, if you look in Wireshark, which we've done that the last couple labs, you'll see that the Ethernet 2 is the frame type. And the Ethernet 2 has been used for quite some time now. And there's been, with IP version 6, the payload is going to change a little bit, and then the frame is going to change when we finally change that. All right, so let's look at some of this encryption protocol information. So encryption protocols is where the data is scrambled so that it can't be read. So the encryption uses a mathematical algorithm or a formula to change the data, and then it's transmitted, then it's unencrypted on the other end by the other device. And the reason for that is what's known as the CIA triad, or the textbook here calls it the encryption evaluated by 3 benchmarks. And the CIA is the confidentiality, the integrity, and the availability. And confidentiality means that only the person intended to see the data should be able to see the data. Integrity means the data hasn't changed. And then the availability means it's available when it needs to be available. Okay, so encryption is used. Here's where it's showing with a private key and to encrypt it, and then the same private key is used to decrypt it. And then this one is showing where we have a private key to encrypt it, and then a public key to unencrypt it. Okay. Now, there's different security protocols. And one of the more common one is the IPsec, or the Internet Protocol Security. And the IPsec is used in a lot of our, kind of in the background of a lot of our encryption devices, like firewalls and load balancers, stuff like that. Okay, so it operates in 2 more modes, either the transport mode or the tunnel mode. Transport mode is when it's transmitted on its channel. IPsec will encrypt it, authenticate it, and then manage the keys. And then a tunnel mode, which is what we find in our virtual private networking, is where it will create its own secure tunnel through an unsecure channel. All right. Another concept of security is with certificates. And we can have either an SSL certificate, which is kind of an obsolete term now, and then the TLS, which is the transport layer security. And these are the security protocols that are found on our devices. So like if we look at the security of, say, Mount Sack's website, where it's the little padlock here, if we look at the site settings, that's not what I wanted. I want to look at the, and so if I look at the certificate, it will tell me the details of the certificate and how it's secured. So like this is using the RSA security protocol. And then it's hashed for the confidentiality is the encryption, and then the integrity is with the hashing, and it's using the SHA-256 hashing algorithm. So if you look at any site that you have to log on to, like the portal for one, that's where you'll see this TLS security, right? And then the next section talks about remote access and some of the remote access protocols. So like here we have FTP, which is not secure. So of course there are versions of it that are secure. The FTP-S and then the SFTP will use other mechanisms to secure it. So FTP-S will add SSL, whereas SFTP will use SSH, the secure shell protocol. And then TFTP is a protocol that uses UDP. And remember, UDP is normally used when we need speed, right? TCP, because of the three-way handshake that you saw last week, slows things down. All right, so here's some terminal programs, Telnet, SSH. And again, we used Telnet last week, right? Where you telnetted into that switch that we set up in Packet Tracer. A secure version of that is SSH. So in this week's lab, we're going to use a new program, a new utility called GNS3. And when you open a terminal to the switch or the router or even the virtual PC, it will open an SSH session. Right, there's other ones, remote desktop, join.me, VNC, and TeamViewer. Here's a screenshot that shows PuTTY, right? And you probably notice this IP address is the same one that we're going to use in this week's lab. Right, there's some other terminals, and then the VPN information is here. And the last section that I want to talk about is this network troubleshooting issues. So the netstat, and let me open a command prompt. So on my machine here, if I go into, and I want to change the font. So if I type netstat and hit enter, it's just going to show me active connections. So on my machine here, I have an active connection to, so my computer's name is Ken-Nuck for the Intel's next unit computing. And then you can see I have a connection that's established with the server here, another server here, and so forth. So netstat will show you all your active or all your current connections, whether they're established or waiting. Now there are switches for netstat, and we can get the help for that with the /?. And let me just show that one screen at a time. So -A will show us all the connections and listening ports. Then N will give us that number in numerical form. So let's do a netstat-AN, and that gives me all of the things on my computer. So while I'm recording this video, you know, it's going out to 18-154.144 .19 on port 443, which is a secure HTTP port. And then you can see there's a bunch of these other sites that are listening on that. So if I look at my browser, and you can see here, you know, I authenticated with Zoom, I'm on Canvas, and then I'm also on the school's portal. So all of those are going to show up here in the NetStat, okay? So if I clear that screen and then go back to the PowerPoint. So that's NetStats. Another protocol, and that uses, this shows us the TCP and the UDP ports. And traceroute actually shows us how many hops are between us and another device. So if I wanted to trace route, and in Windows, it's trace RT. In Linux, you actually spell it all out. And that's because in Windows, there's a traditional, the old DOS version only went up to 8 characters, so they had to truncate it. But if I trace route to, say, www.latimes.com, this will go out and it will say, okay, it's going from my home internet, which is gateway.home, to my ISP. Then my ISP is going to go probably to another ISP. And then it's going to go out Frontier's network. And then through another Frontier network. So Frontier will hop it around. And then finally, I will get to latimes.com. Now, the way this works is it sends an ICMP packet, and each one of these numbers here refers to a hop. So the hop is a router. So go through one router, through another router, through another router. Now notice it's timed out. What that probably means, or what it does mean, not probably, is that that router is not allowing ICMP traffic. So they probably have a firewall rule that blocks any ICMP. So it's going to block ping requests, and it slows the whole process down. Now, obviously, if I come over here and open another tab, LA Times doesn't take that long, right? It gets there real quick. But for the trace route, this can take some time. So now I'm assuming LA Times is in LA somewhere. Maybe not. It could be on the cloud somewhere. But you can kind of get a feel for how your packets get across the network. So I'm going to cancel that. And then let's come back in here. Another program on Linux you can do is TCP dump. And this is a command line packet sniffer, and it is actually part of or is used in Wireshark. So you can run that and it will show you what's going on. Now, devices on the same network cannot have the same MAC address. If they do, that's known as spoofing. And we can go in and, like in VirtualBox, we could change our IP or our MAC address to another known device that would then allow it to pretend that it's that physical hardware. Normally, you don't want to do that. Okay. Now, so it says what protocol must be allowed through a firewall for traceroute to work, and that's the ICMP, right? The ICMP protocol is what traceroute uses. All right, so that's it for the information there. but I do want to show you the well, now you'll see it in lab, but let me just open Packet Tracer just so I can kind of help you with the lab a little bit. So if I have, let's just put a couple of routers on here. We'll use the 2620. And then I'm going to put a couple PCs. And this is going to be similar to the layout that we had in this week's lab. So I'm going to go fast Ethernet and fast Ethernet. Fast Ethernet. Now notice these only have one port. So in GNS3, we have to go in and add a port. In wire or in Packet Tracer, it's a little bit different. First we have to turn it off, and then we can add a port here. No, I don't want that one. Let me do. No, I'll do that TX. So you have to put that in there and then turn it on. Then on this one, I have to do the same thing. So turn off the router, put the port in here, turn it on, and now I can connect. And because these are the same machine, same device, I need to use crossover cable. We'll go 1010. All right, so if I have an IP address over here, so let me just right here, if I have 192.168.1.200 with a subnet mask 255, and then over here I have 192.168.2.200 with the subnet mask. And then on the router, on this side, I have and then on this side of the router over here, and then on my internal ports here, I have 1.1.1.1 and 1.1.1.2. And this one is also, all right. So if that's what my topology looks like, let me bring this up. All right. So if these were running, and obviously I could ping in between, let me get up here. So if I'm trying to ping, let me do a circle. So let me get my tools better. Pick red, here we go. All right. So if I wanted to ping from these two computers here, and then here, you can see there are three separate networks, right? So this network is the 1.0 network. This is the 2.0 network. And this is the 1.1.1.0 network. Now, with the our setup until we have a routing protocol in between these two routers. PC1 or 0 and PC1 will not be able to communicate. And you'll see that in the lab. Because in between our routers, we have to have a routing protocol. Now, that routing protocol is necessary. If we go up to our discussion, we talked about this a little bit last week with our routers, right? With the neighborhood discovery and all that. The purpose of a router is to interconnect two or more networks. So the reason that those devices can't communicate is because there isn't a protocol set up. So in this week's lab, you'll see that. So we're going to use two. We're going to use a distance vector and a link state protocol. The distance vector protocol we use is RIP, and then the link state we'll use is the OSPF. RIP is the routing information protocol, and then OSPF is the open shortest path first. All right, so you'll see that in this week's lab. All right, so that's all I have for this lab or this lecture. And then there are 2 videos for the lab where I walk you through doing the lab for this week as well. All right, and I'll see you in lab.